The next example I want to do is equilibrium. Example 7 on page 50. This is from section 1.2. In this problem, we are given a demand equation, which looks like this. P equals 195 minus 5.8x. That's demand. And a supply equation, P equals 150 plus 3.2x. P is standing for the price in both of these situations. X, again, is the number of units. It's always the number of units. So this would describe people wanting to buy whatever you're producing, and this would describe your supplying that. So, for example, if it was 10 units, you would set the price at 150 plus 32. If it was 10 units, the people would expect the price to be 195 minus 58. So that is how the demand and the supply function work. And what we're looking for in equilibrium is the place where the demand is equal to the supply. So the supplier doesn't make too many or too few. If they make too many, then they would say they'd have to put them on sale and lower the price. If they make too few, they could have made more money. They could have charged more money. So at equilibrium, we're looking for when 195 minus 5.8x equals 150 plus 3.2x. Subtract 150 from both sides, add 5.8 to both sides, divide both sides, and you end up with 5. Now in this particular example, they said that x represented the number of units in millions. So the answer to this question would be 5 million units would be equilibrium. And then if you take the 5 and plug it into either one of the equations, you can figure out what that price would be. So the price would be either 195 minus 5.8 times 5, or 150 plus 3.2 times 5. And either way, that ends up to be about $166. So if the supplier charges $166, the supply of those items will meet the demand of those items, and that's the ideal place to be.